Find the area bounded by the curves y equals sine of 2x and y equals cosine of x for pi over 6 less than or equal to x less than or equal to pi over 2. Okay, so we have a sine curve, which will be, it'll look as if it's going a little bit fast. And then we have a cosine of x curve. Okay, so I'm just going to go straight to graphing these. So we have y equals, was it cosine? Pretty sure it's cosine. Sine of 2x. Sine of 2x. And y equals, I think it was cosine of x. Let's see here. Cosine of x. Graph these. And we have, okay. And we're going from, I think it was pi over 6 to pi over 2. Pi over 6, pi over 2. So pi over 6 is like 3 divided by 6, which is almost 1/2. And pi over 2 is almost 1.5. So we're going from about here probably, imagine that's right there, to probably there. 4, 0, nope. We'll do pi over 6 less than x less than pi over 2. Come on, Wolfram. Bum. Computing. Yeah, so at this point I feel kind of bad for making Wolfram do all this work. I obviously did something wrong. Let me figure this out. Okay, so we were right about the intersection points, and so it will be sine of 2x minus cosine of x. Sine of 2x minus cosine of x. Okay, go back here, draw this up real quick before I forget it. So we have this, and we have this, and that, where this is sine of 2x over cosine of x. And even if for some reason we're wrong and I got those mixed up, that'd be okay because we'd just get a negative area. And we're like, oh, okay, negative area, we meant positive. And then that would sort of solve the problem, at least in this specific case. Okay, so we'll do integral sine of 2x minus cosine of x from pi over 6, that's a terrible pi, over pi over 2. But in the grand scheme of things, even a terrible pi is still usually pretty good. All right, so the integral of sine is negative cosine, and the derivative of negative cosine will be negative sine. And that's just memorizing it from the sine cosine tables. There we go. So one way we can check that, though, is if we go the opposite direction. So if we take the derivative of cosine, we should get the opposite sign of sine. So cosine, negative cosine would give us positive sine, which is true. And then there's going to be a divide by 2 here because we'd have to do a u substitution if you were taking a little bit longer route. And this all depends on how much time you have. If you're really stressed for time, then you just do the mental u equals 2x, du equals x dx, no, 2 dx, du over 2 equals dx, and you do the substitution in there, and what happens is you find a divided by 2 when you have everything solved. So it'll be pi over 6, pi over 2, and now we're just going to plug in numbers. Actually, what I'm going to do is I'm going to switch these real fast and then change the signs. There we go. So this will be cosine of 2x over 2 plus sine of x evaluated from pi over 6, or pi over 2 to pi over 6. Maybe. Yes. Seems reasonable. Possibly. We'll see. Okay. So cosine of pi over 6 times 2 would be pi over 3. I'll write out our unit circle real quick. So we have something that looks kind of like this, where this is our pi over 4. This will be our pi over 6. This will be our pi over 3. And so this will be square root of 3 over 2, 1/2. This will be square root of 2 over 2. And this will be 1/2 square root of 3 over 2. So this is x value, that's the y value. So the cosine of pi over 3 will be 1/2 plus, I know, I'm going to write this out first. That way I don't get too confused. Plus pi over 6 minus, right, and go down just a little bit. Cosine of pi, because pi over 2 times 2 is pi, over 2, plus sine of pi over 2. Okay, so now we can actually go through and solve these things. Oh, blue, my color for taking things to finishing things up. So cosine of pi over 3, cosine is the x value, so 1/2 will become 1/4. Sine of pi over 6 is 1/2 minus cosine of pi is negative 1, so it'll be negative 1/2 plus sine of pi over 2 is 1, so this together will be 1/2. So we have 1/4 plus 1/2. These together is 1/2, but then there's a negative sign, so it'll be minus 1/2. And this will give us a total answer of 1/4. So, whoop, come over here. Haha, it's even a possible answer. Whoop, there we go. So our answer then would be 1/4. I know these area bounded regions, these can be kind of convoluted, a little bit difficult. So let's go back and look and see what we did here. So you generally won't get a problem quite this challenging for an AP exam multiple choice, but you might see something similar to this like in the free response, or you might have a simplified version where you have kind of the idea already given to you and you're basically just asked to do the calculations. So we're given an equation, y equals sine of 2x and y equals cosine of x. We graphed the equation on our calculator, and we found out that at pi over 6, we have sine of 2x over cosine of x. And the two graphs intersect at pi over 6 and pi over 2. We could also find that by setting sine of 2x equals cosine of x, and just solving for x. But that would take a while. So we then do sine of 2x minus cosine of x. The sine of 2x was always above cosine of x over this interval, so we could just do this one integral. We didn't have to break it up into like multiple integrals. We then go through all the math, which was a surprisingly amount of math, revisited our unit circle, and in the end we came to 1/4, which was the answer. That is, the area between these two curves is 1/4. Thanks for joining me. I will see you on the next problem. Go team.